Now it's actually possible to perform different actions on lines that match certain patterns. In other words, you can have one collection of actions for lines that match one pattern, and you can have another collection of lines of actions for lines that match a different pattern. For example, for all the lines that match Australia, that have got the word Australia somewhere in the line, then we just want to print out the very first parameter on that line, whatever that happens to be. If you wanted to specify a different action for a different pattern, then after the closing brace, after the closing curly bracket, you'd put a space and then another pattern, like /England/ and then another set of actions enclosed in braces, and so on. Now these command lines can actually be long, but that's perfectly normal, and I'll show you in a moment how to create actual scripts that really don't have a command line as such. Anyway, we'll have a look at that in a moment. But before we do that, I'll mention that it's actually possible in awk to perform arithmetic, and you might do it like this. We'd assume here that database is a text-based database that contains at least 5 parameters on each line, and maybe the 3rd, 4th and 5th parameters are numeric. So you could add the 3rd and the 4th one together and divide the result by the 5th one on each line, and that would print out the appropriate answer. So very complex awk scripts, if you want to do many actions at once, then what you might do is put them in a separate file. awk-f script file, input file. It's very similar to sed. In fact, it's almost identical to the sed technique. Now that script file that you specify does not have to be executable, and it doesn't have to have an interpreter definition on the very first line. The interpreter definition, of course, being that #! Script file in this case is just a straight text file. It is, of course, possible to create a script file that's standalone. Doesn't need to be called with the awk-f option on the command line. I'll show that to you. It's possible to create standalone awk scripts, and this is an example of a standalone awk script. You start with the script interpreter. On the very first line, you specify that this entire script must be interpreted by the awk program with the -f option, and that is, of course, the password option that we had a look at just a moment ago. So I'll actually show that to you. So here is a standalone awk script. Now this script has actually been made executable, and I've got a script interpreter as the very first line, which will cause this program when I run it to actually be interpreted by awk. Now the last part of the script, which is the brace and then the printf line, I haven't shown you printf yet, but I'll show that to you shortly. That's the part of this probably seen already. All I've done is I've put each curly bracket line, and I've put the print line on a line by itself. What you haven't seen is another set of braces up the top there, following the word begin. And everything inside that first set of braces is a series of statements that is run before the input is even opened for processing. So in here you can do all your initialization. You can print out any headings that you want to print out, you can set up a bunch of variables and so on. And similarly, if you needed to do some processing at the end, after the input had been processed, you could create another set of curly brackets following the word end in capitals. So the only thing that we're actually doing in the beginning part is we're specifying that the field separator is a colon. That's exactly equivalent to doing a -F colon option on the command line. Now I won't go into this any more detail, show you this actually running. And now let's run it. It was, I believe, called password2.awk. I've just put the .awk extension on the end only to distinguish it from the other one, to show that this is an actual standalone script, and we'll process the file, etc. password, and of course it's working as we would expect. So naturally that which ended up being about 10 lines long could easily grow to as many lines as you like. Don't forget to end each line with a semicolon if there's more than one statement between a set of curly brackets. So here is an example. Of course, if I took those 2 lines and put them in a file called myawkscript and made it executable, then I could run it in the following way. Now here's that printf facility that I mentioned just a moment ago. It's actually a slightly more powerful print facility than actually the word print. It's called printf. The F stands for formatting, and it's very similar to the printf function C and C++. It looks like this. Now, actually that entire printf statement that you see there should be enclosed in curly brackets, but we'll just pretend that that is for the moment. I don't really want to go into the ins and outs of printf because it would take quite a long time to explain, probably more than that particular topic warrants at the moment. Suffices to say that there's plenty of documentation about it in the manual pages and also on the internet if you look hard enough. What I will say is that it is possible in this way to specify exactly how many characters wide the printing of each field should be. So here are $6 both being printed out, and that's the %-12s and the %-20s, which specifies that $1 will be printed out in a width of exactly 12 characters. So no matter how many characters there are in each $1, it will be printed out and padded on the right hand side with spaces to a width of 12 characters. And $6 will be printed out in a width of 20 characters. So using this technique, it's actually possible to get output beautifully aligned under headings and so forth. Let me show you what I mean. I'll just modify that script I just showed you. So here it is, slightly rewritten, that awk script that I showed you just a moment ago. I've put in the %-12s and %-20s, so $1 will be printed in a width of 12 and $6 will be printed in a width of 20. Now, for that to be meaningful, I've actually created little headings here, username and directory. Notice that username is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters wide, and directory is 20 characters wide if you go all the way to there. And because these two lines of code have been created inside the begin set of statement block, they will be printed out once and once only at the beginning of the program, whereas this line here will be printed out once for each line of input. So let's see that in action. We'll run this script % and we'll feed it one parameter, which is etc password, and we better pipe the results to more so we can see the heading. And there you go, username and directory, and it's all nicely formatted as you can see. That's the way you achieve that sort of output using awk. Also note that using printf you actually have to specify that you want to have a new line at the end of the output if you do. And new lines are specified just as they are in C and C++ using the \n. If you want a new line followed by a blank line, then obviously put 2 \n's. Okay, so that's really all I want to go into on awk. You can actually buy entire books on awk, so there's no end of learning that you can do just on that program. It's a very powerful, as you can see, text processing language. But I've shown you the basics that you need to get started with simple shell programming. And that actually brings us to the end of the chapter on filters, so let's now have a look at some exercises involving those.